Welcome to the project demonstration of battery management system along with SOC calculation by using PIC microcontroller. So the main application of this project is we are going to check the health of this battery pack using the battery management system. So for to do that we need two major sensors, that is the voltage and temperature sensor. Means continuously we need to monitor the voltage levels inside the battery pack, and also while we applying the load or while we charging the battery we need to check the temperature. So whether it is heating the battery pack or not. So to get this one we are using this temperature sensor as well as voltage sensor. So these two sensors are continuously monitored by the microcontroller. Whenever the battery voltage level is less than the 8 volts, as we are using the 12 volt 1 amp battery pack. So if the battery voltage is less than 8 volts, then the system will on this relay which will acting as a charging switch to this battery pack. So the relay is acting as a switch between the input charging voltage to the battery pack here. At the same time, if the battery this battery pack temperature is more than threshold value, then the system will on this buzzer as indication of audible alert as the battery temperature is high. So that will be monitored by this temperature sensor continuously, and also so-called status continuously monitoring on this 16:2 LCD screen. So to execute all these features, we are providing 230 volts AC input to the transformer, so which will step down the 230 volts AC to 12 volts of AC, and that is input to this regulated power supply board, so which has the three stages: rectification, filtration and regulation. So after rectification we will get the pulsating DC of 12 volts, after filtration we will get the pure DC of 12 volts, and that is the charging voltage through this relay. You can see this, the 12 volts DC input to the battery pack through this relay, and 12 volts DC is input to the 7805 voltage regulator, which will take 12 volts DC input and provide us a 5 volts DC output. That is the operating voltage of our microcontroller motherboard. So from this motherboard, when we get the 5 volts power supply, it start reading input from the input sensors, that is voltage sensor from this potential divider, which is a 10:1 potential divider voltage ratio. Means a microcontroller can't handle the 12 volts, as the operating voltage is 5 volt only. In order to make this voltage to read by the microcontroller, we are going to do the potential divider, so which will divide the voltage in 10:1. If the input voltage is 12 volts, the output from this voltage sensor is 1.2 volts, and in the microcontroller programming language we write the condition of multiplying that input voltage by 10, so that we will get the exact voltage of the battery pack. Same for the temperature sensor is the input. So based on these two inputs, system will control the output module like relay based on the voltage, and buzzer based on the temperature, and LCD is the output module which will continuously show the status of the project directly. And we have interfaced this at the pin number B2 to B7 for the LCD, A0 for the temperature sensor, A1 for the voltage sensor, C4 for the buzzer, C7 for this electromagnetic relay. So these are the main interfacing connections of our project. So let us check with the demonstration. So when we on that, you can see the welcome message on the LCD screen. As of now the battery is fully charged. So if you are while you are demonstrating the project, if the battery voltage is very low, then just disconnect this as indication of a microcontroller. Check the voltage as 0 volts, which is less than the 8 volts. That's why the system switch on this relay. So keep this for at least 1 hour to be fully charged. So once fully charged, you can reconnect this, then the system will check the exact voltage of the battery pack, as you can see that, and the 12.7 is sufficient voltage. That's why the relay is off state. So it doesn't know that whether the 0 volts or you disconnect this one. So if the voltage is less than 8 volts, that is a 0, 1, 2, 3 till 8 volts, then system consider it as a low battery voltage, and the alert message displayed on the LCD, and it will control this relay board. And coming to the SOC SOH values, SOC nothing but state of charging. So while we are charging the battery pack, if the battery pack charge voltage is matches according to the input current, means we are providing the 1 amp current. So 1 amp current voltage has to be increased for every 10 seconds or 15 seconds. If it reaches that voltage levels, then it will go with the 100% of SOC values. Otherwise, if it's not charging according to the current input, then the SOC values affect, and that will be reduced from 100 to 90 or 80. SOH also, if the battery voltage is rapidly discharged, then SOH also will be discharged from 100% to the 90-80 based on the discharging levels of the battery pack. And next, temperature is 29 degrees centigrade as of now. So when we are heating this, so when it crosses the 45 degrees centigrade, then the system will on the buzzer as audible alert. Yeah, we set the limit as of 43 degrees centigrade. Right, and when it is below 43 degrees centigrade, buzzer will be off condition as indication of everything is normal here. So these are the features along with the input and output modules of our project. And coming to the battery rating, we are using 12 volt 1 amp as it consists of 3 4 volt 1 amp batteries are in series. So we'll get 12 volt 1 amp DC battery here.